Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody. It's a new year now, 2026, and getting back to hosting some awesome guests this year. And this is our first show of the year. We really have the honor of being joined today by an awesome guest, Dr. Sheryl Genco, who is Chief Technology Officer of the Advanced Technology Group at Ericsson. They are one of the world's largest and oldest telecom companies involved in building all the equipment, software, services that ultimately make our mobile networks work and all sorts of other really high-tech networks. And she has over 30 years of experience in engineering and management at various organizations, ultimately spanning industrial, entrepreneurial ventures, as well as the public sector. At Ericsson, she spearheads various activities with industry as well as the United States government to exploit not just 5G, but 6G technologies for increased security, economic benefits. And her career is really focused on this really interesting intersection of developing these technologies and ultimately transitioning them and transforming them into actual usable state of the possible ideas and commercial reality. Dr. Genco also serves as a senior advisor to the Defense Innovation Board, as a senior consultant to DARPA commercialization strategy. She also serves on the executive board of CoLabs, which is a really interesting nonprofit consortium of various federal research laboratories institutions. She was previously a member of the senior executive service for the Department of Commerce, where she was the laboratory director of the National Telecommunications and Information Administration Institute for Telecommunication Sciences. And before that, was an engineering director at Honeywell, working on their quantum solutions and really interesting areas of quantum computing. She was also at NIST, where she led the National Advanced Spectrum and Communications Test Network. Really excited about electrical engineering, did her Ph.D. at University of Colorado in Boulder, master's at Syracuse, bachelor's at Northeastern, all focused on electrical engineering. And she's also very active in STEM education and ultimately educating the next generation to some of these really high-tech technologies that are coming our way. A lot of really exciting topics to get into today. Really excited to have her on the show. Dr. Sheryl Genco, thanks so much for taking the time out of schedule today to come on the show.
Well, thank you. I really appreciate having the opportunity to talk to you and talk about STEM and all these other topics. So this is great.
Yeah.
Happy 2026.
Really, absolutely. And
It's going
thanks
to be
for
a great
being the
year.
first show of the year. Yeah, definitely.
Terrific.
Definitely. Sheryl, I love starting off at the beginning to sort of hear about, your early journey. Would love to, go back to just sort of the basics of, what got you initially excited in electrical engineering. And if you could sort of maybe take us up to 1994, that's when you published your dissertation on these really interesting, and I won't talk about, optical locking and all sorts of cool things with lasers and communication, but take us back on what, how these topics fell into your lap and, how you got started in this to begin with.
Yeah, well, like way back in the olden days, my brother was about 10 years older than me, and I have sisters about eight years older than me. And I just adored my brother growing up. And my whole family, was all about my brother, the boy, was good in math. And my sister, the girl, who's, they're quite a bit older than me, we've got to keep that in mind, was good in, the soft stuff, English. And I always want to be like my brother. It was just that simple. I just want to be like my brother. And, I adored him. And so, I mean, I love my sister too, but, you can imagine, young, 8-year-old, toddling along after her big brother. So, so somehow or other, over the course of my career, my high school career and I became great at math. And I went into my counselor's office. Oh, I think the other thing that you should know is that we were not well off growing up. My dad was a roofer in the Northeast, and sometimes there's not money for food.
Yeah.
And so my mom was a hairdresser in the house, but we had a lovely family and a lovely community, and it was great. Come time to figure out how to go to college, and I went into my counselor's office and said, "Look, I am great at math, and I always want to have food on the table. What should I
Yeah.
do?" And I'll never forget, Mrs. Peralta said, "Be an electrical engineer." I said, "Okay, thanks." And then, and then I never looked back. So, that's kind of how it happened. And for me, electrical engineering has been this socioeconomic boon for me. And I just have had a lot of great intersections of different technologies, and we can describe how they're all connected, because I believe every one of my jobs and my careers and different things that I've done are all firmly rooted in electromagnetics. So that's how I became an electrical engineer to start. And had a number of scholarships back in those days to help me get through. Again, we were not a wealthy family. And I did internships and all of the good stuff. So that's how I got to an undergraduate degree. And then I worked for IBM.
Mm-hmm.
And IBM had this fantastic program where they actually flew professors from Syracuse University to the Mid-Hudson Valley to teach graduate programs. And so at that time, it was the heyday, and I was so lucky to have that opportunity with a bunch of my other IBMers to go to Syracuse University
Mm-hmm.
and to get my master's degree. In my undergraduate degree, I was electrical engineering studying power systems, which is the transient analysis of power systems, all about electromagnetics. And my my graduate degree, my master's degree from Syracuse, I studied high-speed circuits and semiconductor physics because we were trying to push the limits of what circuits could do at that time. And so then that's how I got my master's degree in electrical engineering. And then along the way, I was working for IBM. It was a skunk works. It was a
Mm-hmm.
ad tech group where we were trying to develop a massively parallel supercomputer in response to Cray supercomputers. IBM
Yeah.
didn't have one at that time. And so my team, there were about 20 of us that I was in charge of. My team did the switch subsystem, and the switch subsystem required hundreds of connections to the memory and to the CPUs. And so as a result of that, we did great. We had zero defects. We did all kinds of stuff that was never done before, but the switch was essential to get right, get fast, get done, so that the other subsystems could connect. So we did all of that. We worked incredibly hard. My team was great. A number of the folks that I worked with at that time are still there. And
Mm-hmm.
IBM said, "We want you to get your PhD and we'll pay for it." And
There
so
you
they
go.
sent me to the University of Colorado Boulder, full tuition, salary, and fees for 4 years. And I got my degree in optical communications, basically. That was my academic journey.
No, it's an awesome academic journey. It's nice, obviously there's scholarships and people, coming back and forth from IBM to teach you and obviously you working along the way in these internships. So no, it's a great background story. And as I sit here, I tried to prior to this show, Sheryl, and sort of researching all about you, sort of tried to divide up several parts of your journey, sort of pre-Ericsson, but post-dissertation into these different chapters. And you were just talking about one of them because clearly, on one hand, you're learning all about these massively parallel supercomputing systems, developing them, so modeling hurricanes and weather forecasting and all these simulations, great, a lot of data. You're also developing the laser technologies that, hey, let's send a lot of this data there very fast.
So in between, so the IBM piece was actually very sad. I used to say I have blue blood because I loved working for Big Blue. It was fantastic. And I was at the time I finished my degree, IBM had a big downturn. It was a huge downturn. And I could have gone back to IBM and I could have been a chip jockey, but I didn't really want to do that. At that time, we were pushing the envelope of what circuits could do in transmitting speed and accuracy in digital systems. And so we had people with high technology technicians as well as master's degree people actually shaving cycle times off of cables so that all of the signals, hundreds of them, would reach the receivers at the same time electronically. And this is a big problem, and it was very expensive to do. So we knew at IBM that we had to solve that problem. Hence, optical communications was just coming into the fore. However, IBM had its downturn, and at the same time they had this downturn, I was finishing. So I went on and I worked at Ball Aerospace and I ran Ball Aerospace internal research and development for their lasercom systems. And that's how I got into satellite work and other lasercom. And at Ball, some of the IR&D we did was with erbium doped fiber amplifiers, again, semiconductor types of work, a lot of electromagnetics, a lot of those types of things, as well as with DPSK systems, special communication systems for space, where we were actually able to demonstrate theoretical limits in our laboratory. So these were great, big, huge things that we did. Again, all based off of the optical communications. That was interesting. But, time goes on, and I got tapped to, because of my entrepreneurial piece at the NIST, wanted to start up a new communications technology lab, brand new. So it was an entrepreneurial venture within the federal government. So I was all into that. I loved that. That was great. And that was when I managed the National Advanced Communication Test Network inside of the Communications Technology Lab at NIST.
Yeah, that's that's my document, my sort of Sheryl Genco chapter three here, because yeah, I mean you head to NIST, and again, what you're doing here, and again, you take us down this path. Obviously, a lot of spectrum out there in terms of, as you were saying, sort of the electromagnetic spectrum. Like it's got to be shared properly so that NASA's doesn't overlap with DoD and NOAA and all that bit. And so you're thinking about this. At the same time, well, I mean, this is a couple of years later, you're working on quantum computing, where at first I was sitting back thinking, oh, okay, how does this all relate? But then, okay, so we've done a few quantum computing episodes, and we talked about, okay, we gotta make sure that the qubits don't flip the wrong way at the wrong temperature, and then we're dealing with interference and all that. So I see some spectrum and quantum relationship there, and I'll stop there because I'll sound like an idiot if I go any further. But take us down into the road of sort of electromagnetic systems, and I guess how the noise and interference and all that stuff is not good. and we got to make sure it's shared properly across the right parts of our government and all that. Really
yeah. So I did tease out that like it's all connected, and maybe that didn't come out in our original in this beginning part, but it is all connected. And if readers or listeners are thinking about electrical engineering, it's all connected to electrical engineering. Power systems, okay, that's all electromagnetics. Semiconductor physics and high-speed circuits, it's all electromagnetics as a basis. Okay, Ball Aerospace, internal research and development, optical systems for space, erbium doped fiber amplifiers. That's also a lot of semiconductor physics. It's all related, okay? The work at the little SBIR company, that was a livelihood based on electronics mostly. But then when you get to NIST, that's communications, that's spectrum, that's electromagnetics. That's how do you design massive tests that are accurate, that have good repeatability, that are rigorous. that you can't shoot a bullet through, that you can stand on your own 2 feet. And I will say that my team and I got the gold medal from the Department of Commerce for one of those tests.
Yep.
We could talk about that later, but suffice to say, that gold medal was hard in getting. It was we worked so hard, that team, and I have stories upon stories about that team and what we had to do to get that test to be accurate. In the end, the report was factual. It did not have any hyperbole. It had just, the facts. And it was quoted something like, I have to get the exact number, but it was in the neighborhood of 70 times in an 80-some page report from the FCC.
Okay.
Okay, so like almost every page it was quoted in this FCC report. And so you, again, why was it quoted? Because of the rigor and the accuracy of that test and all of the pieces that had to do with electromagnetics and how do you set up tests and how do you learn about what these devices are doing and things like that. So that again is electromagnetics. Now quantum is very interesting. So NIST at the time, of course, had all these Nobel Prize laureates who were doing quantum work, among other things. And Honeywell was setting up their quantum group just down the road. Well, one thing led to another. I end up at Honeywell Quantum being the head of their engineering group. It was a complete entrepreneurial venture. I mean, there were 10 people. We grew that in 2 years to, I don't know, 100, 200 people. We had an office to 2 buildings, 2 laboratories one of which was a SCIF, all the while hiring people, educating them, building actually the trapped ions and all the systems that go into it. So that was a huge, huge entrepreneurial venture to my colleagues at Honeywell and myself. Why is that electrical engineering? Well, I mentioned the word semiconductor physics. Trapped ions are semiconductors. How do you control those trapped ions? With RF frequency, with optical frequencies, and that's how you control what's happening to those ions within the trap. And so my team built all of the laboratory stuff. They built the exquisite electronics and RF systems, the optical systems, the lensing, all the mechanical systems, the software engineering that went into that. And that's what I was the head of. And I learned a lot from the physicists that were there, the lead physicists. And as a matter of fact, in 2025, I had the pleasure of becoming a pioneer in quantum from QWC, a woman pioneer in quantum, which was very, very fun. But again, to me, it was not a revolution. It was an evolution of all the things I've been doing my whole career. Yeah. It was absolutely an evolution. And so that's how I ended up at Honeywell. And then people who know me know this, and I guess we're going to put it on the video here, but I am very, very loyal to my country, and I have a big heart when it comes to my country. And the Secretary of Commerce called while I was at Honeywell and said, we'd like you to come and apply to run our laboratory, be a senior executive service member, and help us with our laboratory. We've got a number of things that we believe that you can help us with. And I'll tell you, it was 5 minutes of midnight when it was due, and I didn't want to leave Honeywell, and I hit send. It was 5 minutes of midnight. And so with that, I end up at NTIA at Commerce, and I ran their laboratory. And it was it was a soup to nuts engineering kind of laboratory for the entire federal government. Had a very important role in regulation and in providing that rigor, that absolute technical rigor for regulation. You cannot do the work of the FCC or NTIA without having a basis, a foundation of solid engineering and testing. And so that was the basis of the lab. And they had financial difficulties or things like that. So I did a number of things along with my colleagues in Washington to help the laboratory bring in money to adapt the laboratory to the 2020 engineering types of problems, to improve the scientific and engineering rigor that goes into these things with new technology. Obviously, there's the need for education and possibilities for these brilliant scientists and engineers there to really, keep their skills current. And then in addition, I ran the facilities with the subset of people that helped me with that. There's a open air test range that I ran, and at one point there was a massive wildfire, and there were two entrances and exits, two total to this Table Mountain facility, and they were both almost engulfed. And we had all kinds of equipment up there. I was up on the ridge until wee hours of the morning, we had great engineers who were evacuating the people, and as well as the most expensive equipment that we could, because we pretty much thought it was going to be succumbed. But and that was something where it's like, that's the moment I knew, yeah, there's all the engineering stuff that I just mentioned, and the renovation of where they're pointed, meaning, like a number of technologies I brought in, and one of the scientists even got a gold medal or bronze medal. I'd have to look it up. Sorry, I think it was a bronze medal while I was there, because of this renovation project on how you're thinking about these problems. However, that fire was the thing I'm most proud of, because we had no loss of life and no loss of equipment. And what I'm probably regret is that I tried to get Congress and others to help us put in another road, another egress. And I was not successful in doing that in my time there. Had I stayed longer, I think I wouldn't have let that go, because the fires, if you've ever been in a fire, you can feel the sound, not just the heat. You can feel the sound, and it was right there. So that's the thing I'm most proud of, and also probably my biggest regret is that I didn't get that third egress put in.
Yeah. No, it's an interesting little human part of it. I mean, we actually was on our previous episode when it was Colonel Chris Grace at the Bluegrass chemical that's destroying all the VX nerve agent. They had a fire there too. So it's our second story about fires around places of national security where you don't want fires. But no, it's just that. No, I'm glad you shared that with us, Cheryl, because it humanizes a lot of this as well. So no, that's a really cool little side anecdote. Let's transition a bit to Ericsson now, because you've used the term skunk works a little bit on the show, talking about sort of the way some of these whether they're major companies like IBM or government organizations have these potentially smaller independent research areas where scientists are encouraged to think more entrepreneurial and not worry about, okay, when do we get a return on this thing, but really think about sort of the advanced technologies. I assume, and I'm wrong, sort of the advanced technology group, and I'd love if you could just introduce sort of why you took the position and sort of where you are, what it's all about in terms of, because I know you sit there and you think about everything from 6G to quantum to distributed cloud computing and all this bit, but what is the Ericsson Advanced Technology Group? And then we'll drill down a little bit on some of the collaborations that you've been very instrumental in creating for the organization.
Sure. So around when I decided to join, it was another startup. So you see this thread. through my career. Everything was not necessarily a skunkworks, but some sort of startup or entrepreneurial venture. And it leverages every single one of my projects, career, whatever, has leveraged this like eagerness that I have to be around vibrance and around, like pulling new things together for the greater good, whatever that is. And so they knocked on my door, and I was very humbled but excited to join. And what the Advanced Technology Group is a small group in the CTO's office. The CTO sits in Sweden, and all of us are effectively the deputy CTOs in the United States for the global CTO or the group CTO. I I have pretty much uh, stopped trying to figure out exactly how Ericsson is organized because it's very confusing. But suffice to say, I am in the global office of the CTO. There's many other CTOs that are affiliated with markets or sales organizations and other things, but the global CTO around research and advancing technologies, emerging technologies.
Mhm.
And so we feed the product groups, if you will.
Mhm.
And so Eric Ekiden, who is absolutely brilliant, hires me, and I join in to this small group of folks who are housed in Santa Clara, but I'm in Washington, D.C.
Okay.
Okay. And so the reason that I was interesting to them and that I decided to join was because I get to do all of the things that I've done in my career. I get to be with an entrepreneurial venture, albeit rather safe because I'm in the CTO's office. I am a CTO for Ericsson. I get to talk about all kinds of communications. I help to monetize 5G with our customers, such as AT&T, T-Mobile, or Verizon. I get to help from my technical background. Anytime anyone in the company calls, I answer, and vice versa. And so it's a great, powerful thing. In and so that's why I joined. That's what I do. I because I'm in Washington, D.C., I am the primary connect to the U.S. federal government and especially the Pentagon. And so Spectrum again is the lifeblood of Ericsson. Ericsson does not own Spectrum, but our customers do. And we support our customers in a number of very, very technical ways around Spectrum. Okay. It's an incredibly difficult field. There's fewer and fewer engineers who can even spell Spectrum, leave alone know about it. And we can talk a little bit more about the STEM stuff later. But
Sure.
but it's really so critical. And Ericsson is all about our customers. We support, support, support. So I do a number of things with the federal government and DARPA, Defense Advanced Research Project Agency, which that just ended. DARPA has a cycle for its consultants, and my cycle just ended. I was a gratuitous service consultant in parallel with my Ericsson job, and my Defense Innovation Board just also ended. They also were suspended this past year. I think I'll probably get back in a while, but in doing that, helping to design how 5G can be used in a battlefield, how 5G is useful for things like smart warehousing, uh, perhaps in Naval Base Coronado, how it could be used for smart ports, perhaps
Mhm.
in, Virginia. And so like I worked a lot with the teams that were the customer teams, but also with inside the Office of the Undersecretary of Defense Research and Engineering, OUSD-R&E, to help formulate and strategize how this can be a real useful technology for the Department of War. And
Yeah.
so that's what I've been doing for Ericsson primarily with them. And one of my favorite projects is with a NATO project in Latvia.
Yeah.
Okay, and I love this project first, and I will say hats off to all the engineers in Ericsson in Sweden. The most unbelievably. So I've said to you a number of times, electromagnetics, really hard. Okay. Radio engineering, really hard. It's really hard. Okay. These folks at Ericsson, and I'm sure at our competitors as well, but these folks at Ericsson that I work with are so brilliant, so brilliant. I learn from them every day, and it's amazing they're capable of from a radio frequency standpoint. And so I am just, I feel like a kid in a China shop working with them. It's not old stodgy technology. It's really cool what they're doing. So this DIBEX, it's called. It's a NATO project, and
Mm-hmm.
we've been doing it a number of years, increasing our activity with them every year. And this past year, we demonstrated some really cool integrated sensing and communications technology. And so
Mm-hmm.
that's probably my favorite project right now. And then the other thing that I do, I have two other things that I just sort of on autopilot now, but I like doing a lot. And is I conduct a 2-day Future G event along with
Mm-hmm.
the Defense Strategy Institute. And I also have been on the board of the IEEE MILCOM, which is probably one of the most technical IEEE conferences that there is. So
Mm-hmm. Mm-hmm.
yeah.
Yeah, let's just focus on that a little bit more because I don't want to gloss over it because it is extremely impressive. And again, aside from obviously the private sector stuff, and you mentioned the ATT partnership, obviously the NATO work, but when it comes to what you were doing, and obviously we're going into specifics because a lot of this is no doubt classified or confidential, but the ability to take DARPA technology. We profiled several, many members, not just the DARPA family, but we had some IARPA guests and ARPA H and all that. But to take sort of these really sort of bleeding edge technologies, then your responsibility to Defense Innovation Board that's saying, hey, we got to have a proper public-private partnership here in place, and then ultimately Ericsson to, hey, we got to translate this is pretty impressive. I mean, this is no joke. I mean, this is not easy stuff, and I'd love to if you could say a little bit about that because I guess most people understand it's not that easy to take something from a really high-tech the Pentagon lab and take it to the market. And this is something you've been very successful at doing in creating this sort of ecosystem and these three legs. And I was wondering if you could just say a couple more words about that. I think it's kind of important.
Yeah, so first with the Defense Innovation Board, I was a researcher, and I don't know the actual name of the report, but I was a researcher who suggested that we do a particular report about how the Department of Defense at that time, now Department of War, how the Department of Defense can transition technology. How can it be more innovative? Again, if you think about everything we just talked about in this session, it's all about that's who I have become and who I've been from the beginning is like, how do you be, entrepreneurial in your mindset and commercialize these things and get them to really work, have that impact, whatever it is, and be up to date. And so that was a really awesome capability. And that report was used as a basis. I mean, you can pick out the language. I don't know firsthand that it was used as a basis, but I did the comparison of the two documents. There were two executive orders that the president issued in the first quarter of
Mm-hmm.
2025, and those two executive orders had a lot of similar language to what was in the DIB report. So that I
Mm-hmm.
was very thankful, again, not knowing whether or not they read it, but certainly I was very thankful to see that. And that's really important. And that's a lot of the work that I'm doing with the Defense Innovation Unit, even now, trying to get sweep in technology. So the Defense Innovation Unit looks out there and says, oh, we have a problem. The Navy has some problem. Let's look out. Oh, this commercial technology is similar. How do we sweep it in? How do we create a program to sweep it in for the benefit of the warfighter? That's what
Mm-hmm.
DIU does. What DARPA does is somewhat the opposite. DARPA says, we want to create new technology, really fundamental new technology, whether it's systems or capabilities or whatever, and we want then to leverage the commercial sector to amplify and to build more of them. Okay. And so I was with the commercial strategies office. The director asked me to join, the director of DARPA, and what I helped with, again, I had several jobs, so I didn't do very much, to be quite frank. But I was the sort of the I was the only person in the group that had a TS SCI clearance, and I was the only PhD electrical engineer there. And so I would get involved in a lot of Tiger teams, things like that. But what their remit is how can we bring how can we commercialize this particular performer's work so that whether it's a PTSD medical solution, or if it's some kind of optical satellite solution, how can we commercialize it? Who should we contact? Things like that. And over the last, I think, year and a half or so, they announced this is all out in the open. They announced what's called DARPA Venture Horizons. And that's really a cool program. And if I go back in, I would like to maybe work on that a little bit. I don't know. But it's really cool. They work you hard at DARPA, though. I don't know.
Yeah,
I don't know. They work you really hard. And
yeah,
so, but what that does is it helps aggregate non-adversarial capital for the benefit of performers.
yeah,
And so that's really a cool program, because I think the number in the commercial sector, say you're a venture capitalist, maybe you know this, Ira, but you're a venture capitalist, you're going to invest $1.
yeah,
You want to get $4 back,
yeah,
right? And so maybe some of our research dollars should have a payback too, and so maybe in that way, by leveraging commercial dollars and commercial know-how, some of
hmm,
these programs could provide more benefit,
yeah,
even more benefit, because the technology is spectacular. It's any given day. That's really, when I'm around new tech and people who are excited about their new tech, that's the best day for me.
mhm.
So
Yeah. I'm
that's
always
how, yeah, sorry, go ahead,
please,
please.
please.
No, please. No, but I was just trying to connect. You had asked about the DARPA piece and why
Yeah,
and I think I run on adrenaline, and I think that that it's easy for me because I can see that what needs done, and I don't know why, but I can, and I'm like, no, this piece is the good. This is the thing that never has been done before, and this piece over here, whether it's for AT&T or T-Mobile or whatever, or whether it's for a DARPA program, we need to connect these two things, or whether it's for Department of Defense, Department of War, um, Future G office. Hey, we got to do this thing in Latvia, because this thing in Latvia is going to demonstrate how we can use all this different 5G technology. And that's what we need to do. And so driving those future leaning demonstrations with real stuff, not just talking, is what I love to do. And that's what I've been doing.
yeah. Again, I've always been amazed by the portfolios that these DARPA folks, manage, and now you bringing sort of the connection in to companies like Ericsson and sort of that creating these ecosystems. Yeah, it's exactly. I mean, what is required to translate these and ultimately make the return for our country, and aside from the national security side, but
Oh
yeah,
yeah.
I
Then
think
there's that.
it's now, and obviously some of these things are so over my head now, but again, thinking out 5 years, 10 years, where this is all going, the type of stuff that gets you excited. If we look at 2030 and beyond, whether that's 6G, whether that's cognitive networks, looking to a little bit of the Ericsson
Yeah.
materials here, and all this stuff is
Yeah.
just one thing cooler after the next. What personally gets you excited as you not just manage the stuff in the advanced technology group, but hey, we got these other things coming our way. We got to talk to these new innovators over
Yeah.
here. Where are we going? 2030, 2035? What gets Sheryl
Yeah.
Genco? What keeps you up at night?
Well, first of all, 20, nothing keeps me up at night. But 2030 is very different than 2035, just so you know. But so 2030, so we'll just say that what's coming is 6G, right? And that's coming in 2030-ish, plus or minus a couple years. And AI has already been changing the networks. So there's AI in the networks, there's AI for the networks, and there's AI to build the networks. And so this has really been fascinating, because we haven't begun to use AI in a way that we could leverage to be more spectrum agile. We are spectrum agile now. We have, I think, hundreds of different radios, hundreds of different capabilities of spectrum that we can ride on. But it'll be really interesting to see how we can manipulate AI along with the system designs that our customers have, how we can manipulate that to have a better, more efficient use of spectrum. And so that's really, really the thing that's, I think, going to happen first. The other thing that, to me, I mean, I live in the future. So my brain is in the future. The work I do is in the future. So I'm about to say this is already done, but it's not done. There's a lot more road to go. There's this integrated sensing and communications. And the reason I say it's done is because we've done some demonstrations, some experiments, and it's going to work. It's great. I see the results of the experiments. I'm really excited, and that's really going to change a lot of things because you think of the Waymos in LA. Right now, yes, they have all of their radars on there, but unmanned vehicles could also get more input, more data input, better data input about the environment by using 6G integrated sensing and communications. And you could learn what's around the corner because guess what? Those radars can't see around the corner. You can learn what's 3 blocks away because you're now connected to a network, and you can do this what we call ISAC. You can do this ISAC sensing from the commercial sector. So that's going to be fascinating. ISAC sensing for enterprise, number of things that could be done there in factories. I think factory automation using 5G, I'm thrilled with that. I am thrilled. And I hope that all these new factories that are coming to the United States, I hope that they look to 5G technology because we can do a lot of it today. Ericsson itself has this really cool factory in Texas that is totally reconfigurable, stuff like that, runs on 5G and makes 5G. It's great. And so I love manufacturing. It's my blue collar roots, and I really hope that we can really have these spectacular factories, whether it's semiconductor factories or car factories, whatever, and use the communications technology fit for purpose. I mean, enterprise 5G is not for every single piece of that chain, but it's fit for purpose, and I think it's really exciting. It's super exciting. As far as quantum comms go, we'll just save that for some time. We're in a skiff.
That's awesome. That's awesome.
Yeah.
Sheryl, one thing I neglected to mention when I introduced you is that in the middle of all of this, while you're thinking of these advanced technologies and protecting the country and building these new business units and entrepreneurial ventures, you also founded a STEM school in early 2000. I think the school has educated somewhere upwards of 20,000 students to date. And I got to tell you, if you were my professor, and I mean, that would be awesome. I would love to learn this stuff. But talk a little bit about, I'm obviously very passionate about enabling the next generation and obviously the prosperity that comes from STEM education. Say a couple words about why you decided to set up the school in the middle of, again, growing your career, and just a little bit of sort of your future visions about, again, why we need to continue to develop the next generation of Sheryl Genco's as we move forward as a country.
Oh, thanks, Ira. Yes, I'm so glad to be able to talk about that. So I mentioned I had babies, and and I love my babies more than anything. So, and I'm who I am. And somewhere along the line, they were in second grade, and I have friends who had daughters who were in different areas of the country as well, and they just happened to have daughters the same age. And this one particular day, my second grader brings home math homework and I can't do it. Okay, this is not 10th grade algebra. This is second grade math. So I call my friends who went to MIT and I say, hey, I can't do this math homework. They're like, oh my God, my daughter brought home the same worksheet. So what is this? So this is when I decided, oh no, this is foo-foo math. my daughter is not going to learn foo-foo math. My daughter is going to learn real math. So with that, I went on my mission, and one thing led to another. I started this math science school with a slew of volunteers who were helping and super great. At one point, I think my friend uh, my friend Denise was helping me manage some like 500 different volunteers who had to go door to door. And then I did the research myself on the scope and sequence and this concept of math as the language of science, and why it's so important, even for traditional historical sort of the humanities. And so like I developed this whole piece and this concept of having laboratory laboratory experiences that are fun, because kids love arts and arts projects, right? And they should love science projects, but they don't love science projects because teachers roll their eyes or whatever happens and they don't do them or whatever. So I came up with this idea along with the other people that I enlisted, there were 4 or 5 folks who were super, super helpful. We went about this mission to create this math science K-8 charter school. And it took us a couple stabs at it. We had to do things like apply to 2 different school districts so we could pit them against each other, and then go to the state school board and get the state school board to agree. And as a matter of fact, little note, the state school board president is the now governor of Colorado. So like all these pieces, I had to personally go. I think she was like 3. I dragged one of my daughters to meet the then governor, Governor Owens, and Mike Kaufman, who is the treasurer of the state of Colorado. And I got her in a little pink dress, and like she was so good. She was so good. I didn't know, who knows? She's 3. And like I dragged her all over the place because the other kid was in school. And so we were able to start this math science school. I'm very proud of it. And it's won all kinds of awards. And I hope that the students appreciate learning real math. And so that's one thing. And then I started a national scholarship for women in electrical engineering. We call it Women in Spectrum. And my vision is to make MILCOM parallel similar to the Grace Hopper conference. Grace Hopper is to computer science what I want MILCOM to be to spectrum or electrical engineering. And so we've done that a number of years, and that's been really exciting. I am absolutely passionate about it. What I see too is that students hesitate to take the hard classes. And I see it firsthand. That same little daughter in the pink outfit, she ended up going into electrical engineering. My other daughter's in chemical engineering.
Yay.
Yeah, other daughter's in chemical engineering, which is the hardest of all engineerings, and then electrical engineering. So but I remember she's at her school and she says, "Mom, I don't have to take field theory." I said, "Oh yeah, you do." Oh yeah, you do. Well, she went on to being spectacular in it, and I'm very proud of her, proud of both my daughters. But suffice to say, that's a problem I see, and I don't know how I'm going to help fix that. But the ABET accreditation does not require electromagnetics for an electrical engineering degree anymore, and it used to require it. And so this is sort of like something that's in the back of my head that I got to take on the next couple of years.
Yeah. Well, I'm sure you'll figure that out. And I just had a son that took electric. He's at NYU doing physics. So yeah, he just had a class in that. So there's one student that's taking it.
Hey, that's great. Good job.
Yeah. But no, I can sympathize with you. I was there around in the early 2000s, also looking at those math sheets. I'm like, what the hell is this? Yeah, I understand exactly where you're going with that. But no, that's awesome. Last thing, Cheryl, while we have you today, and I do so appreciate the time you're spending with us. I see, that coming up in March is the Future G Conference for Defense and Warfare Summit, where you'll be speaking there. anything else that we should know about in these first couple months of the year in terms of other public-facing initiatives that you're going to be involved in, where people can, run into you, meet you, listen to you present? Anything else that I missed also while we have you today, please?
Oh, well, thank you. That's my big one in March. Thank you for bringing that up. I appreciate it. It happens somewhat randomly throughout the year. I sometimes get called to speak at embassies or at other events. I'm not speaking in January that I know of, but I am looking forward to AI and Spectrum events that are happening in the later spring. So hopefully, I get to meet other people. I love face to face. I always say I'm better in 3D than I am in 2D. So I look forward to, please, if anyone sees this and wants to meet me, they can reach out on LinkedIn too.
Absolutely. We'll put that link in the show notes. But
Thank you.
yeah, I mean, just such an impressive journey, Sheryl. I'm so glad we had the opportunity to finally hook up and do this episode and tell your story to the broader world here. And just really looking forward to continue to follow you and everything you're going to be doing in 2026 and 2030 and see what, see what happens after that. Hopefully we can do a follow-up episode, but really impressive work. Again, for everybody out there that's going to be listening to this episode across the various podcast networks or who will be watching on the YouTube channel, you've been spending time with Dr. Sheryl Genco, Chief Technology Officer, Advanced Technology Group at Ericsson. Sheryl, I want to thank you again for taking the time out of your schedule to talk to us and educate us for a little while. Thank you for everything you do there, not just for on the commercial side, but for national security. And as we like to see here on our show, thanks for helping to create a better and safer tomorrow for all of us via what you do. Really an awesome story.
Thank you for your time, and I really appreciate having this chance to talk to y'all.
Really great having you.